5 German tank crews burn alive, never understanding why they died. February 1943, Kasserine Pass, North Africa. Blinding dust, choking smoke, burning steel. 5 Panzers destroyed in minutes. 5 Shermans advance untouched. 10 American radios coordinate every move. German transmitters fade, receivers hiss, commanders shout into dead microphones. German engineering worships armor and optics, but starves radios, doctrine, and redundancy. If German tanks were truly superior, why did their crews die deaf? 5 American Shermans advance through smoke and debris. Their movement appears impossibly smooth. Each tank shifts, halts, and surges forward with uncanny timing. No flags rise, no flares streak into the sky, no messengers weave between vehicles. Yet the Shermans move as if guided by a single will. Inside supposedly superior Panzers, German crews watch their lions buckle. Radios crackle and fade. Orders vanish mid-sentence. Static replaces leadership. German engineering worships armor, optics, and guns. It neglects ruthless universal communication. Here, invisible American radio waves decide who lives and who burns. The imbalance is brutal and irreversible. In Panzer IVs equipped with FUG 5 sets, commanders strain to hear their own leaders. 10-watt transmitters, impressive in the 1930s, now barely reach through dust, terrain, and engine roar. Many vehicles carry only receivers. Crews can listen, but they cannot speak. They cannot report what they see. They cannot call for help. Across the battlefield, inside every Sherman, the SCR 508 hums with life. Orders travel instantly. Warnings leap from tank to tank. 8,000 kilometers from Detroit's assembly lines, the most decisive technological advantage of the war reveals itself. It does not sit in armor thickness or gun caliber. It lives in invisible electromagnetic waves, binding American tanks into a single fighting organism. This transformation begins long before Tunisia. In July 1941, while German forces pushed deep into the Soviet Union, the United States Army standardizes the Signal Corps radio sets SSR-58, SCR-08, and SCR-538 for all medium tanks. American planners commit to a simple principle. Every tank will talk, every tank will listen. In Chicago, at the Galvin Manufacturing Company, later known as Motorola, a small team turns that principle into hardware. Daniel E. Noble conceives the application of FM technology in military vehicles. Henryk Magnuski, principal RF engineer, wrestles with heat, vibration, dust, and electrical noise inside armored hulls. Their creation weighs 181 pounds. Metal, glass, and copper fuse into a dense block of circuitry. Installed inside the M4 Sherman, it turns each tank into a node in what becomes the world's first true battlefield network. At the heart of the SCR-508, the BC-604 transmitter pushes 25 watts of power. It operates between 20.0 and 27.9 megahertz, with 10 preset channels locked by crystal control. No drifting frequencies. Dual BC-603 receivers let a commander listen to 2 nets at once. Platoon traffic on one, company or higher command on the other. Orders flow down. Reports flow up. Coordination becomes continuous rather than occasional. The real revolution lies in FM itself. Edwin Armstrong's technology, licensed to the military, rejects fragile amplitude modulation. Every spark plug, every electric motor, every track movement throws noise into AM receivers. German crews hear crackle and hiss, where Americans hear words. During artillery barrages, German radios dissolve into static. American FM sets keep speaking. In November 1942, Operation Torch brings American armor to North Africa. The 2nd Armored Division lands near Safi and Fedala. There Shermans roll ashore with SCR-508 radios already installed and tested. Across the desert, the Arracourt operates under strict communication limits. In a standard German platoon of 5 tanks, only 1 or 2 carry full FUG 5 transceivers. The rest carry FUG 2 receivers only. Orders travel outward. Information rarely travels back. German platoons function through rigid hierarchy. The leader transmits. Subordinates obey through movement rather than words. When a command tank burns, its multiple antennas mark the wreck. The rest of the platoon loses its voice. Coordination collapses. Against an enemy where every tank can transmit, this structure becomes a fatal weakness. Any surviving Sherman can assume control. Between 14 and 24 February 1943, the Battle of Kasserine Pass exposes this imbalance. On the ground, German forces achieve tactical success. American units fall back. Vehicles burn along the passes. Yet within the chaos, something new appears. Scattered elements of the United States 1st Armored Division maintain contact across nearly 50 miles of broken terrain. Crews who have never met coordinate movements. Tanks warn each other of ambushes. Artillery support arrives in response to clear, rapid radio calls. German signals intelligence units listen in. They intercept American transmissions and note the clarity. Reports from the 10th Panzer Division's intelligence section describe American units maintaining communication at ranges where German sets produce only static. More alarming, every American tank appears able to transmit. The old assumption that only command vehicles carry full radios no longer holds. As the war moves north, the technical gap widens. In September 1943, American armor lands in Italy. Mountainous terrain should favor German communications doctrine. Valleys block line of sight. Ridges break formations. Visual signals become impossible. Instead, FM technology grows even more valuable. The SCR-508 handles multipath reflections and terrain interference far better than AM sets. American tanks coordinate through ravines and over ridgelines, where German radios fall silent. Reports from the United States 1st Armored Division describe routine coordination at distances where German crews hear nothing but noise. Platoons separated by entire ridges time their attacks with precision. German doctrine insists such maneuvers require visual contact. The battlefield proves otherwise. On 6 June 1944, Sherman tanks grind down the ramps of landing craft onto the beaches of Normandy. Water washes over their hulls. Engines strain. Yet their SCR-508 radios maintain contact with naval fire support offshore. Tank commanders receive corrections and fire missions from ships they cannot see. German technology cannot match this link. Behind the beaches, in the hedgerow country, a new problem appears. Tank radios and infantry radios speak different electromagnetic languages. The SCR-508 in the Shermans operates between 20.0 and 27.9 MHz. The infantry's SCR-300 backpack sets operate between 40.0 and 48.0 MHz. In the bocage, this gap turns deadly. German infantry armed with Panzerfausts creep close to American tanks. Nearby American riflemen see the danger but lack a direct line into the steel hulls. Within weeks, American improvisation closes the gap. Crews weld ammunition boxes to the rear of their tanks. Inside each box they mount an EE-8 field telephone wired directly into the tank's intercom. Infantrymen lift the handset and speak to the crew inside. By the time Operation Cobra begins in late July, this simple field modification spreads widely. Tank infantry cooperation changes almost overnight. Between 25 and 30 July 1944, Operation Cobra unleashes the full potential of American radio superiority. The 2nd Armored Division under Major General Edward H. Brooks coordinates more than 200 Shermans through layered radio nets. Platoons, companies, battalions, and higher headquarters all share a common electromagnetic language. Across the lines, the Panzer Lehr Division faces them. Once the pride of German armored forces, Panzer Lehr now suffers from communication poverty. Many of its tanks operate without radios. Crews rely on hand signals and flags in terrain, where hedgerows limit visibility to less than 100 meters. The few functioning sets struggle with interference in short range. To German defenders, American tanks appear almost omniscient. A threat revealed on one flank triggers movement on another. Artillery strikes arrive within minutes of target identification. Shermans shift positions in response to reports from units miles away. The battlefield fills with American voices carried by FM waves. German units, fragmented and deaf, react slowly and often too late. The irony runs deep. Germany had pioneered radio use in armored warfare. Heinz Guderian, architect of Blitzkrieg, had insisted on radios in tanks since the 1920s. His 1937 book Achtung Panzer stressed communication as the core of armored success. Early German victories in Poland and France rely heavily on radio-equipped command vehicles. By 1943, German industry cannot supply enough sets to match its own doctrine. Production figures reveal the crisis. In 1943, Germany manufactures around 5,700 medium tanks. Fewer than 2,000 FUG transceivers leave the factories. Many go to command vehicles and assault guns. Regular tank units receive what remains. The result is a front line where perhaps 1 in 5 tanks can transmit. The rest fight as mute followers. Soviet forces suffer even worse. The T-34, the most produced Allied tank, often enters combat without any radio at all. Soviet doctrine leans on flags and pre-battle planning. In 1941, this limitation proves disastrous against German formations that coordinate by radio. By 1943, Lend-Lease shipments bring some American sets, including SCR-508 radios, to Soviet command tanks. Even by war's end, only about 25% of Soviet tanks carry radios. Against this backdrop, American achievement stands out. While the Soviet Union struggles to equip a quarter of its tanks with any radios, the United States reaches 100% deployment of sophisticated FM systems. Motorola's Chicago factory becomes a symbol of this effort. Before the war, the company builds car radios. Wartime conversion demands new tooling, new processes, and new tolerances. Each SCR-508 contains 2,748 individual components. The BC604 transmitter alone holds 474 capacitors and 385 resistors. Crystal oscillators must hold frequency within tight limits, despite heat, cold, and constant vibration. By 1942, production reaches 3,800 SCR-508 family sets. In 1944, it reaches 24,000. Total wartime production passes 50,000 units. These numbers align almost exactly with Sherman tank production, 49,324 M. 4 Shermans roll out during the war. Each receives a radio set. No other nation approaches this level of universal deployment. Technical details translate directly into battlefield behavior. Crystal-controlled stability means tanks can preset channels before combat. Crews know exactly which frequency links to platoon, company, or artillery support. German FUG-5 sets, tuned by variable capacitors, drift off frequency under stress. Operators constantly adjust dials. Messages fade and blur. The dual receiver configuration in the SCR-508 allows commanders to listen to 2 nets at once. A platoon leader can hear his own tanks and his company commander simultaneously. Orders arrive without delay. Situational awareness extends beyond what any single crew can see. Inside the Sherman, the BC606 intercom ties the crew together. Throat microphones and noise-canceling headphones let driver, gunner, loader, and commander share information instantly. A loader spotting a threat can alert the commander without shouting over the engine. Many German tanks lack such systems. Crews tap shoulders, point, or yell through steel and noise. Power management adds another layer of advantage. The SCR-508 operates on either 12 or 24 volts, adjusting automatically. A dynamotor power supply smooths and filters the current, stripping away electrical noise. German sets draw power directly from vehicle systems. Every spark becomes static. Every fluctuation distorts speech. These technical edges reshape American doctrine. The combat command structure, built around flexible task forces, depends entirely on reliable radios. Commanders assemble ad hoc groups of tanks, infantry, artillery, and engineers for specific missions. Because every vehicle shares compatible communication, these groups function as coherent units rather than improvised clusters. German commanders, bound by limited communications, cling to rigid organizational charts. In September 1944, during the Battle of Arracourt, the 4th Armored Division faces several German Panzer brigades equipped with Panther tanks. On paper, the Germans hold the advantage. Their tanks carry thicker armor and more powerful guns. Every Sherman can report enemy positions the moment they appear. Tank destroyers receive targeting information from tanks that never see the enemy directly. Artillery observers in Sherman command tanks call in barrages within minutes. Over 3 weeks, the 4th Armored destroys 281 German armored vehicles while losing only 41 Shermans. A 7-to-1 kill ratio emerges, driven not by armor or gun caliber, but by information flow. Throughout the war, German intelligence fails to grasp the full meaning of this advantage. Reports mention American coordination and discipline. A captured assessment from September 1944 states that American tank units show good radio discipline and rigid procedures. The report attributes performance to training, not technology. The absence of FM, the universal deployment of transceivers, and the dual receiver architecture remain largely unrecognized. German tactics continue to target supposed command tanks, identified by antenna clusters. Crews believe that destroying these vehicles will blind American units. They do not realize that every Sherman can assume command. Ambushes are planned on the assumption that American tanks will lose coordination once separated by terrain. Instead, radio contact maintains cohesion even when units cannot see each other. By March 1945, as American forces approach the Rhine, communication superiority reaches its peak. The capture of the Ludendorff Bridge at Remagen illustrates this clearly. When elements of the 9th Armored Division find the bridge still standing, radio reports race rearward within minutes. 1st Army Headquarters receives the news almost immediately. Orders ripple outward. Within an hour, divisions across the front begin shifting to exploit the opportunity. German forces, dependent on telephone lines, struggle to respond. Allied aircraft have shredded much of the wired network. Field telephones fall silent. Radio coverage remains patchy and limited. American units, linked by FM nets, build an interlocking defense around the bridgehead. Tank platoons from different battalions integrate their fires. German counterattacks arrive piecemeal, poorly coordinated, and fall under concentrated American response. In April 1945, the encirclement of the Ruhr pocket shows the final form of this advantage. American armored columns from the 1st and 9th Armies coordinate a complex double envelopment almost entirely by radio. Inside the pocket, 325,000 German troops find themselves cut off. American fighter bombers, guided by radio-equipped forward air controllers, strike German communication centers. Headquarters lose contact with subordinate units. Field Marshal Walter Model's final messages before silence describe the situation. No contact with adjacent units, no communication with higher headquarters. Fighting continues, but coordination becomes impossible. For American crews, radios shape the emotional landscape of combat. Even when a Sherman stands alone on a ridge or in a village street, its crew remains connected. Voices from other tanks, from artillery batteries, from higher command, flow through their headsets. Isolation lessens. Information replaces guesswork. German tankers experience the opposite. Many fight with only a receiver or with no radio at all. They see only what lies directly ahead. They react to local threats without knowing the larger picture. Otto Carius, one of Germany's most successful tank commanders, later describes in his memoir the constant struggle against limited communication. Orders arrive late or not at all. Units stumble into battle with incomplete understanding. After the war, American technical intelligence teams examine captured German equipment. Their reports confirm what the battlefield already suggested. German tanks often carry superior armor and armament. Their communications, however, lag years behind. United States Army Technical Intelligence Report 176 concludes that German tank radios stand roughly 5 years behind American systems. The absence of FM, the scarcity of transceivers, and poor electrical suppression combine into a critical weakness. Soviet evaluators reach similar conclusions. Given access to captured German sets, they choose to emulate American designs for post-war development. Production and deployment statistics crystallize the story. American SCR-5808, SCR-528, and SCR-538 radios exceed 50,000 units produced. Sherman tanks reach 49,324 units. Deployment rate stands at 100%. Transmission power reaches 25 watts. Crystal control holds frequency within plus or minus 0.01%. Effective range, while moving, stretches to around 7 miles. Stationary, it extends to 10 or even 15 miles. German FUG-5 transceivers total roughly 6,000 units. Medium and heavy tank production reaches about 12,000 vehicles. Full transceiver deployment hovers near 20%. Transmission power remains at 10 watts. Frequency stability drifts around plus or minus 1%. Range while moving often falls between 0.5 and 1 mile. Stationary, it reaches 2 to 3 miles under good conditions. These numbers translate into artillery response times. American units often secure fire missions within 3 to 5 minutes. German units wait 15 to 30 minutes. American tanks achieve near universal coordination. German tanks operate with full communication in only a fraction of cases. The principles forged in these years shape armored warfare long after 1945. Modern main battle tanks carry digital communication suites, but their conceptual lineage runs straight back to the SCR-508. Universal deployment, reliable links, and integrated crew intercoms remain standard. In the 1950s, the rebuilt German Bundeswehr absorbs these lessons. Every Leopard tank receives comprehensive radio equipment. Training manuals emphasize communication as a decisive factor. One manual states that the defeat of superior German tanks by inferior American vehicles with superior radios proves that information dominance outweighs platform superiority. Later conflicts echoed this pattern. In 1991, coalition forces with advanced communication networks face Iraqi units equipped with individually capable Soviet-designed tanks but inferior radios. Coalition formations maneuver and strike with coordination reminiscent of Sherman units in 1944. In 2003, American forces again demonstrate that network-centric warfare overmatches platform-centric forces. The story of Sherman tank radio superiority reveals a victory fought in the electromagnetic spectrum. German crews often never see this battlefield. They feel its effects through sudden artillery, coordinated flanking moves, and enemy units that seem to react with impossible speed. The SCR-508 transforms the M4 Sherman from an adequate medium tank into part of a larger weapon system. Each vehicle becomes one element in a distributed intelligence spread across the battlefield. The 75mm gun, the sloped armor, and the reliable engine matter. Yet the 181 pounds of radio equipment inside the hull often decide whether those strengths can be brought to bear at the right place and time. German forces learn this through hard experience. At Kasserine Pass, in Italy's mountains, in the hedgerows of France, and in the final battles inside Germany, American tanks display coordination that German doctrine insists requires visual contact. The Wehrmacht never develops an effective counter because it never fully understands the scale of the technological gap. At Germany's surrender, Field Marshal Wilhelm Keitel reportedly remarks that Germany knew how to build better tanks, but America knew how to make them work together. Whether perfectly quoted or not, the sentiment reflects a deeper reality. The United States does not simply build 49,324 Shermans. It builds 49,324 interconnected nodes in an armored battlefield network. Historians later describe a revolution in military affairs under the term network-centric warfare. Its roots lie not in satellites or digital links, but in the moment when the first Sherman with an SCR-508 enters combat in 1942. From that point onward, the side with superior communications begins to outweigh the side with superior individual weapons. The network begins to defeat the platform. The connected begin to overmatch the isolated. For German commanders, recognition comes too late. By the time they understand that most of their tanks fight as solitary machines, While every Sherman fights as part of a coordinated whole, the war's outcome stands largely fixed. The failure to prioritize and solve the communication deficit becomes one of the great industrial and operational miscalculations of the conflict. In the end, the electromagnetic waves carried by SCR-5-808 radios proved more decisive than the armor-piercing rounds fired by German 88mm guns. The ability to share information instantly, to align movements across miles, to bring artillery and air power into the fight within minutes, shapes outcomes more reliably than any single tank's armor or gun. Across 3 continents, German troops encountered this reality. They faced not just numerical superiority, but a hidden technological edge in the dimension that matters most for modern warfare. They face an enemy that fights